Okay, today we're going to look at Chapter 5, Decimals, and we're looking specifically at Section 5.7, Introduction to Square Roots. So one thing to note is for this section, you'll be given a table, a list of squares. So we'll have x's and the x squared, so from 0 to 25, and then the appropriate squared values of each of those. So you don't have to memorize these will be given to you. So to start with, we're going to look at what is the square of a number. And so usually we call our number x, and then whatever that number is we're going to square it. And so that's going to look like x squared. And so we call that the square of the number x. And so what we can do is we can be given different numbers for x. And let's say if we given 9. Well, what we do is we're going to say, well, if we square that, that's going to become x squared is equal to 9 squared, which is really just 9 times 9. And if we don't remember that, we can go to our table and see that 9 squared is equal to 81. Okay, so here what we can do is if we have, say, a negative 9, what happens there? Well, that's negative 9, the whole thing inside of parentheses squared. And so that means we're going to take a negative 9 times negative 9. So that's going to become a plus because when you take that negative times a negative, those become pluses. And so then it's really back to 9 times 9, and that's, again, 81. Same thing kind of works for any other number. So say we had 12, well, that's going to be 12 squared when we're looking for the square of the number. So that's going to be 12 times 12. And hopefully you know at least the first 12, and that would be 144. But again, if you don't, it's on the table here, so you don't have to worry about it. Now, if we have x is negative 12, again, we have to put the whole thing inside of the parentheses, the negative 12, and we're squaring that. So what we do is we take negative 12 times negative 12, and when we do that, that becomes negative times negative is positive, and then just 12 times 12 is back to the 144. So that's when we square a number. But what happens if we start over here in the right column and we have a number and we want to find the square root? Well, what happens is we're going to look at the following. So say if a squared is equal to x, then our a is going to be the square root of whatever x was. So if x was, say, 121, well, what we want to do is we want to find the square root of that. So if we take the square of that, we come over here, and that's going to be our a value. So in this case, it's going to be 11. So we're going to write this as a, if we have this, we want to find the square root, we're going to say a is equal to the square root of x. But when we have the equation set up like this, we also have to know that it's going to be also equal to the opposite, because if we remember up here, if we took 9 and squared it, we got 81. But if we took a negative 9 and squared it, we got 81 as well. Same with the 12s. And so we don't just get only a positive number, we get a positive number, and we also get the opposite of that number, okay? And when we're looking at square roots, we have this sign here that's called the radical sign. And then underneath it is the x, and that's called the radicand. So let's say we have 81. So that's going to be our value of x. And we want to take the square root of it. Well, when we do it, what we usually have is we say, you know, we want to find the square root of 81. And so we know because of that, we want the plus and minus square root of 81. So when we take the plus square root of 81, that gives us 9, because if we take and look at the square root of 81, that gives us what x is, which is 9. But we also can get the negative square root of 81, and then the opposite of that is a negative 9, okay? And if we went back the other way like we did up here, negative 9 times negative 9 is positive 81. 9 times 9 is positive 81. So it works that direction. And so kind of like I said up here, you know, when we take the square root of the number, we get both the positive and the negative of that number. So we take the square root of 81, we get a plus 9, and we get a minus 9, okay? So let's say we want to find the square root of the given number. So the numbers that we're given are 49 and negative 49 and a 289. So those are the three numbers we want to find the square root of. So when we do that, we want to write plus and minus the square root. Or we can just say, well, we know we're going to get a plus and a minus value is. So what is the square root of 49? Well, if we don't know, we can look in our table, and that's going to be equal to 7. And we know that we're going to get a plus and a minus of it, so it's going to be a plus 7 and a minus 7. So when we did this, we could have said, well, we want to find plus or minus the square root of 49. And so, the plus square root is 7, the minus is the negative 7. And we do our check, minus 7 times a minus 7 is plus 49, and 7 times 7 is 49 as well. Now let's go and do number 3 before we get to number 2. So we want to take the square root of 289. So again, when we do that, we're going to end up with a plus or minus the square root of 289. So if we don't know that one, that's a little harder. We look here, and square root of that is going to be 17. And so we know we're going to get a plus 17, and we're going to get a minus 17, because a negative 17 times negative 17, those become positive, and we get 289. And then 17 times 17 is just 289. Now here, what's going to happen is we're going to get plus or minus the square root of a negative 49. Do we see any negatives over here in our column of x squareds? I don't see any negatives. And that's because if we want to find the square root of a negative number, that's going to be an imaginary number. That's beyond what this class is. So this one is going to give us imaginary number, and we don't have that in this class. And so basically what we're going to say is no two real numbers will be true, because if you take a negative 7 times a negative 7, that'll give us a positive 49, and a 7 times 7 is going to give us 49. So there is no solution to this one in this class. So we can't find that, or we can say it's undefined. Okay, that's another way to write the solution of this one. So it's square root of a negative number. We can't do that one. Again, and that's because, if we look at our list of squares over here, all of them are positive. So we can find square roots of these, but we can't find square roots of negative numbers. All right, so here it says list all square roots of the given answer. If none, write none. Again, you can also write undefined if possible. So what we want to do is we want to find the square root of that. So we want to find plus or minus the square root of 361. That's what it's asking for. List all square roots of the given number. So we need to have the plus and the minus. Now 361, if we don't know what that is, that's here. And so that's equal to 19. So our answer is going to be a plus 19 and a negative 19. So that's all the square roots of 361. Now this one, we want plus or minus the square root of a negative 400. Well, again, here we have a negative under the radical. That's an imaginary number, and so we don't have that capability in this class. And so in this case, they ask us to write none, so we can just write none. Now here 324, well, we know we're going to have plus or minus the square root of 324. Now we just have to find that on our table over here. Well, 324 is here, so plus or minus square root of that is going to be equal to plus or minus 18. And that would be our square root of 324. Now on the next one again, we're going to have plus or minus the square root of negative 100. Again, that's going to be an imaginary number, which we can't do in this class. And so we would just write none. Okay. And again, sometimes they're going to ask you to write none. Sometimes they're going to ask you to write undefined or no solution. You just have to kind of go with the flow, and whatever they ask you to do is what you're going to put for the answer. All right, so this one says find the exact square root. So it doesn't say find all the solutions. It says find the exact solution to what's shown here. So what they want is exactly what is the square root of 576. So, well, 576, the square root of that is equal to 24. Now it doesn't say what is the plus from all those solutions. It just says what is that one. And so that one is just 24. Now the second one says, what is the negative square root of 16? Well, square root of 16 is 4. The opposite of that is a negative 4. So we just have to put that negative in front of whatever the square root of 16 was, and we have our answer. All right, this one, guess what? We have that negative under the radical again. And because of that, that's imaginary. Now this time they say write undefined, and so it's undefined. Okay. Now if this had been, just a negative square root of positive 36 underneath, then we would say, okay, well, that's going to be a negative 6. But because it's a negative 36 under the radical, that's undefined. Now this one, what do? We have a square root of 100 over 81. Well, what we can do is we can break this down into the square root of 100 over the square root of 81. And so we just break our fraction down. We put the square root of each on top and bottom. Well, the square root of 100 is just 10. The square root of 81, that's 9. And so our solution is just 10 over 9. Similarly, here what we can do is we can break this down into the square root of 625 over the square root of 324. Well, if you don't know what 625 is, we come over here and look clear to the bottom, and that's equal to 25. Now 324, we come all the way over here, that's 18. And so the square root of 625 over 324 is equal to 25 over 18. All right, so this one here, we have kind of an algebra solution. So we have to go ahead and just fill in what we know as we go. So minus 2 minus 7 times, well, the square root of 576, we know, is just 24. So that's 24. Now we have to multiply and then add and subtract. So if we take 24 times 7, that's going to be 28. That's going to be 14, 15, 16. That's a negative. So we have a negative 168 for this piece, and minus 2 more. So that's going to give us negative 170 for our final answer. Okay. And so you just have to do some things in pieces, and in this case, the piece was you had to go ahead and do the square root first, then multiply it times the 7, and then subtract off your 2, and then that gives you the negative 170. All right, so this one we have the square root of 7 squared. So that one, basically, if we take the square root of something squared, that square root and the squared cancel each other, and we just have a 7. And this one we have a square root and a squared. Those are going to cancel each other, plus 24. And so we just take 7 plus 24, and we get 31. Now, if we want to look at it a different way, what we can do is we can go ahead and square. Let's go to a blank page. We can take and say, well, that square root of 7 squared plus the square root of the, what was it again, 24 squared. Well, that's going to be the square root of 49 plus the square root of 24 squared is equal to 576, I believe, if we go back up to our table. Yes, 576. And so now we have this square root of this and a square root of that. Well, we can look in our table and a square root of 49 was 7. The square root of this is 24. And so that's equal to 31. So, you know, before what we did is the square root cancels the square and we got 7. That square root cancels that squared and we got 24. And here what we had done is we just went ahead and squared each of them, and then we took the square roots. But that kind of shows you both ways you get the same answer depending on how you want to look at it. All right, so the next one we have, well, now we have 8 minus 6 times, well, the square root of 400. Well, 400 is 20, and so that's going to be 6 times 20. Well, 6 times 20 is 120, so that's going to be 8 minus 120. And if we need to, we can say, well, 120 on top minus the 8, and that's going to give us 112. And the bigger one is negative, so that's going to give us a negative 112. Okay. So that would be our answer to this. And again, it's kind of an algebra problem where you have to kind of work your way down and get your final answer. All right, so now here, okay, now we want the opposite of the square root of 441. Well, 441, if we look down here, is equal to 21. So the opposite of that is going to be a negative 21. Now here's square root of 25. That's 5. We want the opposite of that, so that's a negative 5. Now this one is going to be a little trickier because guess what? We don't have any decimals over here, do we? But we do have something that has 81 in it. 81, the square root of that is 9. And so what we have to think about on this one is, how do we get the square root of 81 to be 9, or the square root of 0.81? What does that equal? Well, that's going to equal 0.9. And if we think about that, what we've done is, we've moved a decimal over twice to get to that point. And so then if we take and move the decimal over for the next one, we are only going to move over one, because this, if we think about this one, what we have is, if we take this one and move over twice, we get to the 1. But to get that, we only would move it over 1 here. And so it's kind of a factor of by 10. And so that would be our answer. And if we want to check 0.9 times 0.9, 9 times 9 is 81. And we move the decimal 1, 2 places, 1, 2 places, and that gives us our 0.81. And so if there's 2 decimals in here, then we just have 1 out here. So the same thing's going to work here. So when we have the 9, that's going to be up here, just the square root of that's going to be 3. But because we have the 0.09, we're going to have to move and convert it to 0.3 to get their square root. So the square root of 9 is 3. We have 2 decimals here. We only have 1 here. And if we try it out again, 0.3 times 0.3, well, 3 times 3 is 9. We move it 1, 2. So we move it 1, 2, and we get 0.9. So that's going to be how you do that one. So now let's do this one, 0.64. Well, that's going to be up here. That's going to be 8. Now, based on what we had before, if there's 2 here, we're going to end up with 1 out here. So that should be 0.8. And so again, if we try that, 0.8 times 0.8, that's going to be 64. We move the decimal 1, 2, 1, 2, and that gives us the 0.64. And so that is the correct answer. All right, so this one, now we have to actually take the square root of this squared plus this squared. Now, when you have a square root of all of that, we actually have to multiply 7 times 7 and 24 times 24, add those two together, and then we can take the square root. So this becomes the square root of 7 times 7 is 49, plus 24 times 24 is 576. And so that becomes a square root of, well, if we add that, that looks to be 25, then that comes 2, that's a 6, so that's going to be 625. Well, guess what? That square root is equal to just 25, and so that would be our solution. So we actually have to expand this out to become 49 plus 576, add those together, and then we can take our square root to get 25. Now this one, we have a minus 1 plus the square root of 625. Well, we know the square root of 625 is equal to 25, so minus 1 plus 25. So 25 minus 1 is 24, and that would be our solution there. Okay, so that's finding square roots and using our table here. So that's the nice type. What we're going to do now is we're actually going to estimate a square root, and we're going to do the work ourselves. So we're going to have a number that's not one of these perfect squares, and we're going to have to find the square root. And so what we're going to do is we're kind of estimate what it is. And how to do that? Well, we're going to be given some number to find a square root of, and we're going to have to determine 2 integers that square root lies between. Okay, so once we have that, then we're going to draw a number line and locate the approximate location of the square root between the 2 integers found where it lies between. And then we're going to estimate to the nearest 10th or 100th or whatever it asks. But most of the time it's going to ask for the 10th. Okay, and so what we want to do is find the square root to the nearest 10th of the square root of 58. Well, square root of 58, where is that going to lie? Well, that's going to lie somewhere between 49 and 64. And so that means our number should lie somewhere between 7 and 8. And so what I'm going to do is I'm going to draw the number line, and, well, that's not a very good number line. And so I'm going to draw a number line. My finger doesn't stick here. And so this end is going to be the low number, 49. And the upper end is going to be the 64. And so I have to figure out how many spaces are going to be in there. So, and I might not actually label that last one as 64. I might be smarter to say that's just kind of the end. And so if I get done before then, I can label it there. So 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64. So then I really don't need that last one. And so now that's going to be my 64. And what I want to do is find out where was that 58 there. So that was 49, 50, 51, 52, 53, 54, 55, 56, 57, 58. So that's my 58. Okay. And so now I kind of look and see, how many spaces are on each side. And what we're going to do is we're trying to estimate that decimal place. Where is it at? It's 7 point something, we know, but 7 point what? Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's the ninth spot. And then 10, 11, 12, 13, 14, 15. That's the 15th spot. Okay. So what we have is basically 9 out of 15 is the position it's in here. And so what we need to do is figure out that, and that should give us a first guess as far as our decimal. And so if we take 15 into 9, that's going to give us our first guess. And so 15 times 6 should give us actually 90. And so I'm going to guess my decimal is going to be 7.6. So my first guess is 7.6. So 7.6 times 7.6, what does that give me? Does that give me 58? Well, 6 times 6 is 36. And 7 times 6 is 42, 43, 44, 45. And that's 42. That's 49, 53. So that's 6, that's 7, that's 7, that's 5. Move it 1, 2 decimals. So 57.76. Okay. Now, the key is I have to decide what is the closest. So if I go 7.5, if I multiply 7.5 times 7.5, is that going to work? Well, that's going to give me a number less than 57.6, and I want really 58. So I'm going to go the other way. I'm going to take and see what does 7.7 times 7.7 give me, because that's going to be higher, and I want to see if it's closer to 58 or is this number closer to 58. So 7 times 7 is 49. Oops, 9. Okay. So then I have 49, 53. And that's going to be the same thing, 9, 3, 5. So it's a 9. That's going to be a 12. That's going to be a 9. That's going to be a 5. And then 1, 2 decimal places. So 59.29. So that's way over 58. And so my closest number for the square root to the nearest tenth for square root of 58 is actually going to be square root of 58 is approximately 7.6, and that is going to be my guess for the square root of this number, approximately 7.6. And again, all they ask for here is to the nearest tenth. And so this is how I'm going to do my square roots by hand. I'm going to first draw my number line. I'm going to see how many numbers are here before, how many numbers are total, and then take and divide that. And that gives me my first estimate as far as what decimal am I going to use. Then I add that decimal to whatever the lower value was, in this case the 7, multiply those two out and see what I get. Now, if it's under my number, then I add 1/10 because I'm going by tenths, and I got 7.7 times 7.7, and that number is way above 58. That's 1.29 above. This one's only like 0.24 below. So that means 7.6 is going to be my guesstimate as far as the nearest tenth estimate for the square root of 58. So let's do some more here. All right, so 79. Well, 79, if we look over here, that's going to be between these two. So it's going to be between basically 8 and 9. Okay. So what am I going to do? I'm going to again draw my number line. And I'm going to go now between 64 and 81. So if I go up here and draw my number line, so here's 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81. All right, so that time I was smart and labeled them as I went. Now, how many spaces are there between 64 and 79? Well, that looks to be, if I subtract that, 15. And if I take and subtract that one, that looks to be 17. I'm just taking 81 minus 64, and that should give me 17. Now I have to divide those out. Okay, so 17 into 15. And so that's going to be 0. If I take 7, that's going to be too small. If I take 8, 56, 8 that's 13. That's still pretty small. What about a 9? Would 9 work? That's going to be 63. That's going to be 15. That's going to be too big. So I think it's going to actually be the 8. 17 times 8, 56. That's going to be 13, 6. And because that one's going to be, that's going to be 153. So it's going to be between 8 and 9, kind of looks like, basically. So my best guess is going to be 0.8. All right. So my guess is going to be 8.8. And so if I multiply those out, because I had the 8 here, because if I did 9, it's going to be bigger than that. So 8 times 8 is 64. 64 plus 6 is going to be 70. And then I have 407. It's 4477. Move it 1, 2 decimals. So that's 77.4. So to the nearest tenth, I'm pretty far under. So that means I need to try one higher. Well, one higher is 8.9. So let's try that. So 9 times 9 is 81. That's 72 plus 8 is 80. That's going to be 72. That's 64 plus 7, that's 71. That's 1, 2, 9, 7. 2 spaces, so 79.21. Now, which one is closer to 79? Is 77.44 or 79.21? Well, 79.21 is just 0.21 over. This is more than 1 different here. And so actually my answer for the nearest square root, the square root of 79, is going to give me approximately the 8.9. So that's what my approximate square root will be. Okay. And again, what we do is we draw our number line, figure out the fraction. In this case, it was 0.8 was the best one that actually divided and left us with a number. And then after that, you know, we just had to figure out, well, what's 8.8 times 8.8? Well, that was a number too small. 8.9 times 8.9, it was a little big, but it was closer to 79 than the other one. And so 8.9 then was going to be our answer. All right, so let's do 27 now. Well, where's 27? Well, 27 is going to be between those two. So it's going to be 5 point something. And it's probably going to be closer to like 5.2 than it is to 5.9 because it's closer to 25 than it is to 36. So we'll draw our number line again. And here that's going to be 25, 26, 27. 28, 29, 30, 31, 32, 33, 34, 35, 36. And so that's our last one. And so here we have 2 over 11. All right. So now we need to divide that. And so 11 goes into 2. And that goes in once. That's going to be 11. That's a 9. and bring down our 0. So that's going to be 8. So I'm thinking it's going to be either a 1 or a 2 here, because 8 might round up that 1 to 2, and that might be the best number. So again, let's try both of them. So our value is going to be 5.1 times 5.1. So that's going to give us a 1, a 5, a 5, and a 25. That's a 1, a 10, a 6, a 2, move the decimal twice, 26.01 for the 1. Now if we do the 2, which I think looks to be like it probably is going to be better, 2 times 2 is 4, and 2 times 5 is 10. That's going to be 10. That's going to be 26. That's a 4, a 0, a 7, a 2, 2 decimal places. So which one is closer to 27? This one is. Even though it's over, it's closer. And so I'm going to say the square root of 27 is approximately 5.2. And so that then would be my solution. Okay. All right, a couple more. So 44. Well, where's 44? It's going to be somewhere between these two numbers here. And so what we have is somewhere between 36 and 49. So we draw our number line again. So that's 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49. A little extension. Oh, yeah, 49. Now this is going to stay. All right, so now what do we have? Well, we have 1, 2, 3, 4, 5, 6, 7, 8, and 9 disappears, and over 13. And so what does that equal? Well, 13 goes into 8.00. If we take that times, I don't know, 5, that's going to be 15, that's 65. 13 times 7 maybe is a bigger number. What would that be? 21. That's going to be too big. So 6, that's going to be 18. That's going to be 7. So it looks like a 6 is going to be 78. 2, 0, that's 1. So I'm betting just based on this, it's going to be 6.6. Okay. So 6.6 is my first guess. So 6 times 6 is 36. That's going to be 39. And then 6, 9, 3. That's 6. That's 15. That's 13. That's 4. And this was a 15 here. So it's 43.56. That's less than that. So let's try 6.7. And if we multiply that, 7 times 7 is 49. That's 42 plus 4 is 46. Here that's 42. That's 36 plus 4 is 40. That's 9, that's 8, that's 4, that's a 4. And 2 spaces. So 44.89 or 43.56. Well, those are pretty close to both. 44.89, that's 0.89 over. This one is going to be 0.44 under. So this one is actually the closer one. So I'm going to say the square root of 44 is approximately 6.6. Okay. All right. Now one thing to do. This really, it takes just a lot of practice doing a bunch of different numbers. And so, you know, while I can show you a lot on this, you have to really practice this yourself to kind of understand this. So 75, where does that lie? Well, 75 lies in this region here. So it's going to be 8 point something. Looks like it's closer to the 9 than it is to the 8. So probably 8.6 maybe we'll assume is going to be our guess. So if we go here, we have our 64 is our first one, then 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, then 76, 77, 78, 79, 80, 81. So we have what? 75 minus 64, that's going to give us 11. 81 minus 64 is going to give us what? 17. And so what does that tell us? Well, we have to take and divide 17 into 11. All right, so 17 times what? Well, 17, and I said it's going to be closer to this, so maybe times 6. And so that's going to be 42. That's 10, 102. 17 more. It's going to be too big. So that's going to work. So we'll say that's 102. Subtract, that's 8. And so that's going to be probably 17 times 4 is 28. That's going to be 68. Another 17. That's going to be 15, 6, 7, 85. That's too big. So it looks to be 0.64. It might be probably a 0.6 to the nearest tenth. So let's try that. So we'll have 8.6 times 8.6. 6 times 6 is 36. 6 times 8 is 48, 49, 50, 51. That's going to be, again, 48. That's going to be 64 plus 4 is 68. So that's 6, that's 9, that's 13, that's 7, 73.96. So that's under, but what if we do 8.7? How far over is that? Well, 7 and 7 is 49. That's 56, and so it's going to be 60. That's going to be 56. That's 64, 69. So that's a 9. That's a 6. That's a 15. That's 75.69. All right. So now if we take and subtract that, that's going to give us 0.69 over. This one is going to be 1.04, and so it really looks like 8.7 is going to be the better number of the two as far as the rounding. So I'm going to say the square root of 75 is approximately 8.7 to the nearest tenth. Okay. All right, again, a lot of practice is going to help you on these, and that's going to be the key to actually being able to solve all of these types of problems.